Good morning all. I am Indumathi, working as Assistant Professor in the Department of Biomedical Engineering, School of Bioengineering, Bharat Institute of Higher Education Research. Today we are going to discuss about the multiplexing. So, what is meant by multiplexing? You can say in any communication system, that is, it may be either digital signal, digital system or analog system. We need a communication channel for a transmission. So this channel can be a wired medium or it may be a wireless link. It is not practical to allocate individual channels for each user. Therefore, a group of signals that are combined together and sent over a common channel. For this, we use multiplexers. Therefore, multiplexer is known as a group of signals that are combined together and sent over a common channel. For this, we use multiplexers. So, multiplexer is a device that allows digital information from several sources to be routed onto a single line for transmission to a single destination. A demultiplexer does the reverse operation of multiplexing. In this demultiplexer, it takes digital information from a single line and distributes it to a given number of output lines. So, multiplexer is called as many to one and demultiplexer is called as one to many. Then, multiplexing is the process of combining a multiple signals into a one signal over a shared medium. And similarly, if the analog signals are multiplexed, then it is called as analog multiplexing. Similarly, if the digital signals are multiplexed, then it is called as digital multiplexing. Multiplexing was first developed in telephone system. A number of signals were combined to send through a single cable. So the process of multiplexing divides a communication channel into several number of logical channels, allotting each one for a different message signal or a data stream to be transferred. The device that does multiplexing can be called as a multiplexer or mixer, and the device that does demultiplexing can be called as a demultiplexer or demixer. In advantage, the advantage of multiplexing is that we can transmit a large number of signals to a single medium. It is the advantage of multiplexing. This channel can be a physical medium like a coaxial cable, metallic conductor, or any other wireless link, and will have to handle multiple signals at a time. Thus, the cost of transmission can be reduced. And this figure shows the concept of multiplexer and demultiplexer. So, multiplexer shows the n number of input lines will be converted into the single output line, and the single in demultiplexer side, single input line is given into the multiple n output lines. And then next is types of multiplexer. The multiplexer is basically divided into the two types, analog and then digital. This analog multiplexer again divided into the two categories, that is called as frequency division multiplexing, wavelength division multiplexing, that is FDM and then WDM. And digital multiplexer is classified into time division multiplexing. This time division multiplexing is denoted as TDM. This TDM is divided into the two categories, that is called as synchronous time division multiplexing and asynchronous time division multiplexing. Even though the transmission occurs on the same channel, they do not necessarily occur at the same time instant. In general, we know that the multiplexing is a technique. Several messages are combined in a composite signal so that this can be transmitted over a common channel. So when you are transmitting the various signals over a single line, what happens? So it is essential for us to keep the signals apart to avoid interference between them. So adjacent signals can be able to mix with each other, and then it can be easily separated at the receiving end, also very important thing. So domains in which multiplexing can be accomplished are time, phase, frequency, wavelength, etc. Multiplexing circuits are called as multiplexer and then mixer. Frequency division multiplexing. Frequency division multiplexing is networking technique which combines many signals into single one and then transmitted the combined signal through a common communication channel. In receiver side, the opposite process carried out, which is known as demultiplexing, which extracts the individual channel signals. The transmitter side performs multiplexing and the receiver side performs the demultiplexing. In frequency division multiplexing, the total bandwidth available in a communication medium is divided into a series of non-overlapping frequency bands. So we have divided into number of frequency band, that is also non-overlapping frequency bands. So to avoid this overlapping frequency, we have using the broadband. That is, each of these bands, divided bands, is used to carry a separate signal. In FDM, all users using some common channel at full time, but each of the users is allocated with a different frequency for transmission for avoiding the signal interference. But even though sometimes there is a possibility of crosstalk because all the users use the same transmission medium and also at the same time. So due to this, crosstalk will be happen. So FDM is used for analog signal transmission, and it does not need any synchronization between the transmitter and the receiver. In this frequency division multiplexing, large number of signals can be transmitted simultaneously. This frequency division multiplexing suffers the problem of crosstalk, as already told you, and intermodulation distortion takes place. Frequency division multiplexing is used in amplitude modulation and FM broadcasting, public telephone networks, and cable TV network system. And this is the different frequencies are allotted to different users in frequency division multiplexing. For example, user 1 uses the orange color band of frequencies allotted to the user 1, and yellow color band is allotted to user 2. Similarly, the black color band is allotted for the user 4. So this is about the frequency division multiplexing. So next one is wavelength division multiplexing. So fiber optic communication require a different kind of multiplexer, that is called a wavelength division multiplexing. It is on analog multiplexing techniques and it is designed for a high data rate, capability fiber cable. In this technique, the bandwidth of the communication channel should be greater than the combined bandwidth of the individual channels. So this is the important criteria. That is, in wavelength division multiplexing, the bandwidth of the communication channel should be greater than the combined bandwidth of the individual channels, that is individual input signals. In WDM signals, the signals are converted to the light signals. Each light which has a different wavelength. So this different wavelength is transmitted through the fiber cable. In wavelength division multiplexing, the transmission system divides the optical fiber bandwidth into the number of non-overlapping optical wavelengths. This are all referred as the WDM channels. This wavelength division multiplexing mixes all incoming signals having the different wavelengths, and this incoming signals are transmitted over a common communication channel. In this, a demultiplexer does not the reverse operation and separates the wavelengths. This multiplexing mechanism provides a much higher available transmission capacity. Wavelength division multiplexing is divided into the two types. What is that? Unidirectional WDM and then bidirectional WDM. So in this type, that is in unidirectional WDM, the data is sent only from one side and received on the other side. Multiplexing of the wavelength occurs on the sender side and the demultiplexing of the wavelength takes place on the receiver side. In bidirectional way, in bidirectional type, the data can be sent from both sides, which means that the both sides can do multiplexing and demultiplexing. But in unidirectional, the data is sent from only one side and it will be received on the other side. So both sides can do only one function, but in bidirectional, the multiplexing and demultiplexing takes place in the both sides. So WDM is divided into the two types. One is unidirectional, another one is the bidirectional wavelength division multiplexing. In unidirectional WDM, the data is sent only from one side and it is received on the other side. and in bidirectional way. So the data can be sent from both sides, which means that both sides can do multiplexing operation and then demultiplexing operations. And then advantages of WDM. The WDM is a full duplex transmission is possible with the help of bidirectional. And this WDM is easy to configure. And the optical components we are using in this system are more reliable and it is providing more higher bandwidth. And this by using this WDM, the simultaneous transmission is possible. And this WDM is a very low cost and easy system expansion. This WDM, we are using the optical signal, so it provides a high security and faster access to the new channel. These are all the advantages of wavelength division multiplexing. And in disadvantages, the disadvantages of wavelength division multiplexing is we are using the optical signals, so optical fiber we are using, so the cost of the system increases because of the optical components. Inefficiency in bandwidth utilization because each user is allotted of each single separate bandwidth. So difficulty in wavelength tuning and difficulty in cascaded topology. And this is the representation of WDM multiplexing. So in input side transponders, we are having link 1 to link 2, link 3, link 4. These are the different uses and all these different uses is given into the multiplexer. So the multiplexer is combined all the spool rings and given as a single output to the transmission channel. In the multiplexer, so the single input is received and it is given into the different transponders, that is link 1 to link 4. So next type is frequency division multiplexing. So this frequency division multiplexing, it shows the concept of demodulation. It is the block diagram of FDM transmitter. It shows the concept of demodulation of frequency division multiplexing signal at the receiving side. In this FDM receiver, the antenna, in the FDM transmitter, channel 1 to channel N are taken as the input channels. Okay, signal 1, signal 2, signal 3, etc. up to signal N. This channels reach at the input of the corresponding modulator, where it receives another signal from a crystal oscillator that is called as a carrier signal, which is a high frequency signal. Always modulating signal is low frequency signal and then carrier signal is a high frequency signal. So the carrier signal is modulated with the input signal. Different modulators use different carrier signals for modulation purpose. So it should be noted that the frequency band of one modulator will not make any interference to the frequency band of the other modulator because each uses the different frequency level. So each of the modulator produces the corresponding modulated signal at their output. All the output of the modulators will be given to an adder or mixer circuit. So from that space, that is from there, it is given to the modulator for further shift of total bandwidth. Finally, this higher frequency signal will be transmitted over the channel. So this is about the frequency division multiplexing transmitter. And then this is the block diagram of frequency division multiplexing receiver. And this FDM receiver shows the concept of demodulation of FDM signal at the receiving side. In this, the antenna receives the multiplexed modulated signal from the transmitter. This signal will be weaker at the receiver side so that it is necessary to amplify the signal. If once the amplification is done at the initial stage of the receiver, then this amplified signal is forwarded to the B modulator. Now the output of the demodulator will be given to the band pass filter. Which are well designed within the central frequency of the carriers are used individually at the transmitting side. Thus, the output of each bandpass filter will be the same as that of the originally modulated output of the corresponding modulator. Then we use the corresponding individual demodulators to recover the original signal. It is about the frequency division multiplexing receiver. And then we are going to see about advantages and then disadvantages of the frequency division multiplexing. The advantage is the sense a large number of in frequency division multiplexing, a large number of signals can be transmitted simultaneously. And in this, the demodulation of frequency division multiplexing is an easy way. And disadvantages of WDM. The communication channel must have a very large bandwidth, and in this intermodulation discussion takes place. And in this FDM, a large number of modulators and filters are required. All the FDM's channels get affected due to the wideband banding. And applications of FDM. FDM is used for FM and AM radio broadcasting, and also it is used in television broadcasting, and also it is used in first generation cellular telephone. So next one is time division multiplexing. In time division multiplexing, all signals operate with the same frequency at different times. All signals operate with the same frequency at different times. Same frequency but in a different time. It is a technique of transmitting several signals over a single communication channel by dividing the time frame into equal slots. Dividing the time frame into equal slots. Here, the signal is transmitted can occupy the total bandwidth of the channel, and each signal will be transmitted in its specified time period only. In time division multiplexing, all signals operates at same frequency at different time slots. And this diagram shows the schematic diagram of time division multiplexing operation. So from this, it is clear that a circular ring, okay, in this the circular ring has been splitted into the equal segments. Okay, the circular ring is splitted into the equal segment that is denoted as A to H, A, B, C, D, etc. to H. And also, it is noted that there is a movable arm attached to the inner ring. The movable arm is attached to the inner ring, and it slides over the 8 segments over the ring. The 8 segments are 8 inputs, and the selector moves in a clockwise direction from A to H. After completing one revolution, what will happen? Again, it starts. Then output is taken from the inner ring that contains the signal from only one slot at a time. So the output is taken from the inner ring that contains the signal from only one slot at a time. The same arrangement is also made for at a receiving side. The two inner rings of the transmitting and receiving stations are rotated at the same speed and they are synchronized. Thus, the signal at segment A of the transmitter will reach the segment A of the receiver in the period the arm is contacting the segment A. The same in the case of the other segment also. Whatever we have followed in A segment, that the same is repeated for the other segment also, that is B to H, the same thing is followed. The time division multiplexing is used when the transmission rate of the media is greater than the total transmission rate of the sources. Here, each signal is allotted a definite amount of time. The slots are too small so that the transmission appears to be a parallel because of the slots are too small so that it appears to be parallel. In time division multiplexing, all the signals to be transmitted are not transmitted simultaneously, but instead of that, they are transmitted one by one. Serially, it will be transmitted. When all the signals are transmitted once on the transmission channel, it is said to be one cycle of completion. It is said to be one cycle of completion. So, synchronization between the multiplexer and demultiplexer is major issue in time division multiplexing operation. If the multiplexer is So the time division multiplexing is used when data transmission rate of media is greater than the total transmission rate of sources. Here, each signal is allotted to a definite amount of time. So these slots are too small so that the transmission appears to be parallel. In time division multiplexing, all the signals to be transmitted are not transmitted simultaneously. What happened? Then instead they are transmitted one by one. So that synchronization is a main problem in the time division multiplexing. If the multiplexer and demultiplexer is a major issue in is synchronized. So it should be synchronized properly. So a bit belonging to one channel may be received by another channel. Therefore, one or more synchronization bits are generally added to the beginning of each frame. So these bits are called as framing bits. These bits are added, we are adding extra bits. These bits are called as a framing bits. And this framing bits allows the demultiplexer to synchronize with the incoming stream so that it can separate the time slots accurately. So normally this synchronization information consists of 1 bit per frame, alternating between 0 and then 1. There are two types of time division multiplexing, that is synchronous tedium. Another one is a asynchronous tedium, otherwise it is called as a statistical time division multiplexing or intelligent time division multiplexing. So first one is synchronous time division multiplexing. In synchronous time division multiplexing, the slots are arranged in a round robin manner. If there are n sources, so if there are n slots, then a single frame consists of n time slots, and each time slot is dedicated to exactly one source for carrying data from the corresponding input. Each source places its data to the link only when the corresponding slot arrives. In synchronous time division multiplexing, if a device does not have data to send means, then its time slots remains empty. So the transmission of the data with the synchronous time division multiplexing is will be empty. And in this synchronous time division multiplexing, some disadvantages there. So disadvantages since the channel capacity cannot be fully utilized when some sources do not want to send the data. And the capacity of the transmission link must be higher than the total capacity of the input lines. It is very complex to implement the synchronous system. So next type is data transmission with asynchronous time division multiplexing. In synchronous time division multiplexing, if a particular terminal has no data to transmit means at a particular time period, the corresponding start in a frame is wasted or it is an empty. So in asynchronous time division multiplexing is used to overcome the difficulty or disadvantage in the synchronous time division multiplexing. It dynamically allocates the time slots on the demand basis only, okay, on the demand to separate the input channels, thus having the channel capacity. So in this method, the time slots are flexible and the total capacity of the input lines can be greater than the link capacity of the channel. In synchronous time division multiplexing, you can see if there are n input lines, there must be n time slots. But in asynchronous time division multiplexing, what will happen? We have n input lines, then the frame may be less than the n slot also. So you may have a n input lines, but the frame may have a n or less than n slots we can have. So in this, the number of slots in the frame is based on the statistical analysis of the number of input lines. That's why it is called as a statistical time division multiplexing also. And the disadvantage in the time division, asynchronous time division multiplexing is the frames have the different size, and an output slot in synchronous time division multiplexing is totally occupied by data. In statistical time division multiplexing, a slot needs to carry as well as the address of the destination. And this synchronous time division multiplexing requires a buffer and address information is needed as there is no separate slot assigned to the for each user. Next one, 4 division multiplexing. This code division multiplexing is a form of multiplexing. It is also one kind of multiplexing in which the transmitter encode the signal by using a unique chip code. Okay, so in which the transmitter encode the signal, incoming signal, by using some unique chip code. This unique chip code is generated by the pseudo random sequence generator. So in this code division multiplexing, we are using the unique chip code. So this unique chip code is generated by the pseudo random sequence generator. This system uses the spread spectrum communication, and a narrow band signal is spread over a large band of frequency. This will allow us multiple signals from multiple users. Okay, multiple signals from multiple users to share the common communication channel or common communication medium. So in this code division multiplexing system, it involves the modulation of data with the spreading code in the transmitter side. And the receiver also wants to know the same code that is used at the transmitter side in order to decode the signal at the receiving side. Here, different random sequences corresponding to different communication channels from different stations. To separate other channels, this code division multiplexing system assigns each channel with its own code. It assigns each channel with their own code. The main advantages of this code division multiplexing is protection from the interference and tapping, because only one sender and receiver know the spreading code. So due to this thing, we can protect your data from the interference and then tapping. So this code division multiplexing system widely used in second generation and third generation wireless communication system. Advantages of code division multiplexing system is the code division multiplexing does not require any synchronization. It is main advantage in that the code division multiplexing system does not use any synchronization mechanism. In code division multiplexing, more number of users can share the same bandwidth. More n number of users can use the same bandwidth. It is a scalable method. Code division multiplexing is a scalable method, and it is well matched. The code division multiplexing is a well matched with other cellular technology. Interference is reduced because code words are allocated to each user, so that interference is reduced. And in this method, code division multiplexing method, efficient utilization of fixed frequency spectrum. So we are utilizing effectively the fixed frequency spectrum. Disadvantages, the system is more complicated. The system is more complicated because we are using the pseudo code generator, and we are allotting the unique code for each and every user. So it shows us a more complicated system, and the number of users is increases, the overall quality of the service will be decreasing. It is next disadvantages. And also that the system is more complex system, and primarily it is used in a wireless transmission. And next, another kind of multiplexing is an orthogonal frequency division multiplexing. This orthogonal frequency division multiplexing system, a multiplexing technique is used in broadband communication system. So it is a multi-carrier modulation scheme. It is used in 4G broadband communication system and next generation system. So this OFDM is popular in broadband wireless communications wireless system due to its resistance to multi-path fading. This OFDM divides a broadband channel into the multiple parallel narrowband subchannels, and each channel carries a low data rate stream of signals. Each signal carries a low data rate stream of signals. Finally, what will happen? The signals are summing. The signals are added and it will be transmitted as a high data rate. So in an OFDM transmitter, the input signal bits are mapped into a bank of quadrilateral amplitude modulator, which encodes this into the complex symbols. So this is fed to the inverse Fourier transform to ensure the orthogonality of the subchannels. This output is converted into the parallel to serial modulator into the carrier wave, and then this will be transmitted into the air. This will be transmitted into the air at the receiver. The receiver process is performed for recovering the original signal. The advantage of this system is its low computational complexity because of the OFDM may be viewed as very slowly modulated narrowband signals rather than the rapidly modulated wideband signals. So we have discussed about what is maybe multiplexing. So this multiplexing we can divide into the analog multiplexing and then digital multiplexing. So analog multiplexing is divided into the WDM and then frequency division multiplexing, and this one is divided into the time division multiplexing. Time division multiplexing is divided into the synchronous and then asynchronous, and then we have discussed about the code division multiplexing and then OFDM. Thank you.